Good morning everyone, this is Anagon Live and we're back online. Day 16 of Advent of Code has already started. We are a little bit late today because I was still working on part 1 and 2 of day 15. But I just finished it fortunately, and so now we can look at day 16. So let's go to the calendar and have a look. Day 16, Flawed Frequency Transmission. You're 3/4 of the way through the gas giants. Thanks Amy for the congratulations. Yeah, it was a really hard one. So not only do round-trip signals to Earth take 5 hours, but the signal quality is quite bad as well. You can clean up the signal with the Flawed Frequency Transmission algorithm, or FFT. It kind of sounds like a fast Fourier transformation. And I want to know if that's actually what we're gonna do. As input, FFT takes a list of numbers. In the signal you received, your puzzle input, each number is a single digit. Okay, so we get a single number. Yeah, I guess we get a single number with just a lot of digits in it. So let's have a look. Oh wow. Okay, that's just not any number, that's huge. Okay, well let's see if we run into problems with this huge number. Look, no solve, only look. That's okay. You can look. Okay, so we have a huge number. And then what happens? We are going to apply FFT in repeated phases. In each phase, a new list is constructed with the same length as the input list. So, yeah, they're talking about a number, but basically it's a list of digits, and I think that will solve the issue. The new list is also used as the input for the next phase. Okay. And each element in the new list is built by multiplying every value in the input list by a value in a repeating pattern, and then adding up the results. So if the input list were as such, and the pattern for a given element were 1, 2, 3, oh, okay, yeah, the result would be 9 times 1, 8 times 2, 7 times 3, 6 times 1, 5 times 2. That sounds a little bit like the Enigma machine, where you kind of have all these wheels and you increment every wheel to give you a new kind of, I'm not sure if it's a multiplier, I guess it's a multiplier. So basically you're encoding every digit with a new digit. Each input element on the left and each value in the repeating pattern on the right of each multiplication. Yeah, okay, so it's just explaining how this is built up. Then only the ones digit is kept. So 38 becomes 8, minus 17 becomes 7, and so on. So once we multiply, we only take the digit all the way on the right. And minus is also mentioned, but I'm not sure how that could actually work because we have a list of positive numbers. Well, each element in the output array uses all of the same input array elements. Sorry, got distracted there. Well, each element in the output array uses all of the same input array elements. The actual repeating pattern to use depends on which output element is being calculated. Okay, so we all use inputs. Okay, so kind of like this. We have our huge list of numbers here. And every number is using inputs from the same list, like this. These are all kind of arrows, but which ones they use depends on a pattern. So every number has its own pattern, like 1, 2, 3, and 5, minus, I don't know, minus not probably, 9, and so on. Alright. And Userman, you're saying that Python's ints are limited only by RAM. Yeah, I must say I haven't had any issues with integers being too large for Python. It was very easy. And I see Zarankiewicz, also known as Alex, Alex has finished, and Stovoy and Arcanian Archie too. Good job. That's 17 minutes in. So if I'm just as fast as you guys, then I can finish in about... Well, I would still need 18 minutes, of course. That means like in... let's say 45 past. Yeah, you did try a large number. Okay. And you did it in less than 1 second. Cool. Alright, let's continue with the puzzle. So that part was clear. When applying the pattern... Now here we are. The actual repeating pattern to use depends on which output element is calculated. Okay, the base pattern is 0, 1, 0, -1. That's how we're getting the minuses. Then repeat each value in the pattern a number of times, equal to the position in the output list being considered. Okay, we repeat it. We repeat it once for the first, twice for the second element, and so on. Okay, so your list just becomes longer, that's all. And as long as it only becomes longer, nothing really would have changed. Oh no, it would have changed. Ah. Okay, so yeah, I see. You're repeating each element that number of times. Okay. When applying the pattern, skip the very first value exactly once. Okay, so we are starting with this one, yeah? So for the second element, you would actually use this one because you remove 2 zeros. One to skip, one by default, and another one because you're at position 2. Or you could say if it's the second element, you skip 2. So second and 2 match up. After using this process to calculate each element of the output list, the phase is complete and the output list of this phase is used as the new input list for the next phase, if any. Given the input signal here, below are 4 phases of FFT. Okay, so far from how I read it, it seems a pretty straightforward puzzle, and what we need to do is, after 100 phases, what are the first 8 digits of the final output list? I think that is definitely going to be doable. So we're going to do it like this. We're creating a Python file in the right folder, of course. Day 16, that is. Oops, there I just minimized my editor. Nice effect going on. So day 16, Python, let's go. And we have our input here. And why not just do it like this? We'll read it just in one go, digits. And then we need to calculate the patterns, and we have a starting pattern, or base pattern. And that one was 0, 1, 0, -1. And we're going to keep a list of patterns for every digit. That is going to be empty. Maybe we can maybe we can initialize it with nonce and use the same number of length as the length of the digits. So now we have one pattern for every digit, but it's not filled in yet. And then we're going to populate it for I in let's say range 0 till length of digits. Then we're going to calculate the base, or calculate the pattern. So what we need to do is to go over the base pattern. And the pattern for this particular offset is going to be first an empty list. And then for, let's call it D in base pattern, that's the digit. We're going to repeat it a number of times. For N in, and then we're going to repeat it as many times as we need for position I. So we're going to repeat it once for position 0, I think. Let's see if they give an example. Let's see how it is explained. So if the third element is being calculated, it goes like this. So for 0 we get a repetition of 1. And I think with Python, a range that has like 0, 0 would end up being a list, an empty list actually. So we do need to iterate at least once. And then we're going to add it to the pattern. We could probably just repeat it actually. So the pattern is basically just the base pattern, a list of the base pattern, but repeated by the number of, hold on, yeah, repeated by the position in the list plus 1 for every D in the base pattern. That's it. But now we get a list of lists and we need to flatten it. And the way to do that is with maybe collections.flatten or something. I did do it before, but flatten is not the way it's called. Oh yeah, it's called chain. Thanks, userman. That is what I needed, and it's not from the collections list, but it's from itertools. Yeah. And then you need to use the star to kind of explode it. Oh yeah. I wonder then if this is not really exactly the same, just list. I think this is the same. Patterns for position I. You know what? Position, I can use P for that. It's a little bit more clear. And that one is going to be the pattern. I could have just appended it also. Let's just append it. And let's run it and look at all of the patterns that we get. I is not defined. List expected and most 1 arguments got 4. Okay, so that's why you need to use chain. Because list doesn't accept multiple arguments. Oh, what did I just click? I clicked something. And we still get none everywhere. And we are appending. And are we not going over here at all? So we do actually go here. And we're appending the D for D in base pattern. Okay, that's 0, 1 and so on. And then we're repeating the digit D multiple times. And chains give you an iterable. Well, if that's, I'm not sure if that works then. Okay, let's go here and have a look at what this returns. Oh, I'm not sure. I copied something, but not exactly. Copy. Oh yeah, because of my debug mode, it's highlighting the opposite way. So actually, what is not blue is highlighted. Like this. And then we get an error for some reason. But this looks okay. And if we would do it twice, we would get this. And then we just need to chain it. Like this. And we get a chain. But maybe we can make it into a list. And then we get something like this. And that is really correct. Okay. So we'll just add a list around it and see if that helps. And we are appending and no problems there. Okay, so this looks good. Well, not exactly. It doesn't look exactly good. Patterns should definitely contain something more than just digits. Oh, I'm appending. Of course it's going to be containing a lot of nuns because I preceded it. But then still, yeah, I should actually chain it in a different place. The place where I'm making the lists, maybe? Hold on a second. I'm just gonna do this in debug mode and do it by hand and first see what I need to do. So if we evaluate this, we get a list of repeated patterns, yeah, and then we can chain it. That looks also right, but we do have to make it into a list first. No, it's the outside thing that needs to be a list. So that looks fine, but then why do we get a list with only digits and not actually a list with lists? Do we still have music? I have autoplay on, but there is no music. There we go. Nice. Okay, so we're appending, and I'm gonna run it. I think there's just something wrong with the way I'm running my code. It looks like I'm running old code or something. Like it's happened now already 3 times. But I guess we're fine right now. And what was the part about the repeating? It's the repeating pattern on the right of each multiplication. So 1, 2, 3 would do like 1, 2, 3 and then 1, 2 again. That is the pattern. So this one is going to be repeated. So let's look very closely what we need to do. Each element in the new list is built by multiplying every value in the input list by a value in a repeating pattern. Okay. Alright. And we can make a repeating pattern by using cycle. That's something I also learned during Advent of Code. Alright, let's see. So let's just do it. Let's just do a phase. Next phase equals, we get some digits as outputs, as inputs, and we're using patterns as inputs. And but I think I can probably just use the global patterns here. And or we can just make a loop. Why not? Why not make a loop? Or actually, yeah, let's use a for loop. For I in range 0 to 100. And then we're going to calculate each digit. So maybe I'll just make a copy of digits. New digits. How do you make a copy of a string in Python? Maybe you don't need to make a copy. I guess you don't. So A is foo and B is A and then B dot. Can I do append? No. Maybe this, and B now has an exclamation and A doesn't. Oh. Strings are also immutable, thanks userman. Now we have the new digits and we're going to calculate it for position in range 0 till length digits. We are going to calculate it. Respel, you're already done. Nice. Okay, that's part 1. Now part 2. I hope part 2 is not going to be too hard. I have about 1 hour left before I need to catch a train. So if it's not too hard of a puzzle today, then I can actually finish it. That would be great. Okay, so we're going actually over all of the positions, and let's see what we need to do. So we need to go over every position, and every position has its own kind of repeating pattern. And then position 1 will be multiplied by what exactly? This is position 0, 1, 2, and let's say we have here 3 and 5 and 2. Then let's have a look how it will be multiplied. So if the input list is like 9, 8, 7, 6, 5, then we're doing 9 and 8 and 7 and 6 and 5, and that would be the output for what exactly? Would that be the output for position 1? Multiplying every value in the input list by a value in a repeating pattern and then adding up the result. Okay. Yeah, and then so basically the only difference between the output values is going to be based on the pattern. So for the first position, we're using here, we're calculating the first one and we're using all of the values, but we're using pattern 1. And for the second digit, we do the same thing, but we use pattern 2. Okay, so the formula is kind of the same. So let's call it calculate new digit. And well, maybe we don't need that. Maybe we do need that. I do like a little bit of an abstraction here. So we have the digits and the position, and that's it. Okay, so new digits on position P is calculate new digit with all of the digits as input and the position. And so to do that, we need to calculate a sum, or maybe I'll just call it D is 0, and we're going over all of the digits. New digit, like this, new digit, and for D in digits, we're going to multiply, we're going to add it to new digit, and we need to multiply it first with something from the patterns, and the patterns we also need, like this. And which pattern are we going to use? We're going to use, of course, pattern in position P. But now there's something I don't know about patterns, which is that, so they're cycling, right? And so I use the cycle function to store all of them. But I don't know how that actually works in practice. So let's say we import iter tools like this, or maybe from iter tools import cycle. And we have a cycle called C, and it is just a repetition of 1, 2, and 3. And then we say we want position 0. That doesn't work. We can do next on C and get an item, and we can just keep repeating it. Now I'm not sure if I can just say, okay, let's just take the next one, because why actually doesn't it matter? Maybe I can just take the next one. Yeah, I think I can. So the factor is the next one in the pattern. Like factor, and I'll just actually inline that. So that's it, and then we are returning the new digit. And there is an example. The example was this, and I'll just use that one first and see if it works. So then we have the new digits. For every position we've calculated it, and then digits is going to be the new digits, just like that. And I guess we can also do append, just like in the other loop. So we'll start with an empty list, and yeah, again, this is something I could have done with a comprehension, most likely. So now I'm trying to append strings. Okay, so I need to make it into an int first, and here I would also like to make it into an int directly, so I don't have to do too much casting. Oh, and there's something I forgot. We need to take only the right digit, and to do that we can just do a logical binary conjunction with 1, right? Because that takes only the last digit. So if we have no, that takes the last bit. That's not the same thing. We need to divide by 10 and take the remainder. So like this, divide by 10 and take the remainder is 3. Yeah, thanks. Alright, let's run it, and then we need to actually print the digits. Maybe I'll just print it like this. And we'll print the first 8. From 0 till 8. We get a lot of zeros, so that is not right at all. And this is our input. And now there's something I forgot. We do need to skip the first item in the list. No, we need to skip a number of items depending on how far we are in the side in the list. So it is a repeated list like this, but we don't skip it when we're appending it, so we still have like 3 zeros, but just one is removed. So it's not like we remove it here also. So how can we do that? So for every pattern we need to skip a bunch of items. So maybe we can do like, let's say that this is the pattern, and then we need to take a few or something like that. Maybe we can do that. So cycle is, oh man, I didn't, now I lost my import. So import, maybe I'll just break here and use the debug mode to evaluate it. So let's say we have a cycle like 1, 2, 3, and then we want to say take, no. I know we can do it next, but maybe we can have a look at what options are available in cycle. Not so much. Let's look on the internet. Generator, Python generator, take multiple items. I don't see anything. Yep, next view. How to get one at a time? No. Okay, so I'll do it in another way. I'll just repeat it a number of times. Repeat, no, there's no repeat. For skip in range 0 till p, right? So for the first list item we're gonna skip one, so that means we need to at least skip one. Pattern dot next, like this. So now we're skipping a bunch, and we can run it again. Now we can actually get some output. So yeah, that looks a bit better. All right. And do we get the same as we get in the example? So we get 4, 8, 2, 2. That is actually different. So we don't get the right answer. And I'm going to print what we're going to calculate actually. So digit is the digit here. I'll call it D still. And then the pattern that we're going to use is here. Position we're going to have is already provided. And then we'll say, okay, we'll say that D times, hold on, those two are multiplied, and then new D for position B is going to look like this. Yep. Maybe like this. Printing which position we're dealing with. Like this. And here we have to provide what we're actually going to do. And the pattern value is going to be here. Like this. Okay, I think now we got it, probably. And let's run it maybe one time. So we're calculating only one digit now and see if what we get is correct. So for the first position, which is here, we should get 4 in the end. And we are printing right after. So let's actually not pass, but continue. And put a breakpoint there. And run it again till the last breakpoint. And now we get some output. For every digit actually. So what we should get is 1 times 1, but what we do is 1 times 0. So it feels like we probably didn't skip enough. The pattern that we're dealing with here, I haven't shown it actually. So maybe what we can do is print also the pattern No, we cannot print the pattern because it's a generator, and once you go through the generator, you lose your values. So we cannot print it, that's unfortunate. But 0 is definitely not correct. So for the first element, it should be basically 0, 1, 0, minus 1. And here we're skipping a bunch. Let's see if we're skipping correctly. So we say that we should skip, and we're at position 0 right now. So we're skipping once, and then we're still at position 0. No, now we are done skipping, actually. So that seems fine. Skip the very first value exactly once. Oh, wait a second. Skip the very first value exactly once. Okay, so we don't have to skip it the number of times depending on the position. Oh, okay. That was a misinterpretation. It is very simple. It's just going to be like this. Now we run it, and what do we get? Oh, it's a whole lot, of course. After the first iteration, it still doesn't look too correct. Do we skip at the start? When applying the pattern, skip the very first value exactly once. So actually, it is about skipping it as we apply it. So the pattern here, we're going to skip one and then run it again. So after our first iteration, we get something like this. It still doesn't look very correct, I must say. So how many times are we doing next in this code? Oh, we are doing it, yeah, we're doing it once here. But we don't need to do it for every digit, we just need to do it once. Let's first get the pattern. We don't need to do it in the loop. And then skip one and then go. Like that. So, what do we see? We still don't get the right pattern applied. Maybe we can actually look at those patterns after we generate them. So we have an evaluation going on, patterns. So the patterns for 0 is a cycle object, and maybe we cannot make a list out of it. We cannot slice it. We cannot say we want 10. So all I can do is just do next a bunch of times and see what we get. So we should get 0, 1, 0, minus 1. 0, then we get 0 again. Oh, I think I'm repeating the first item also, which I shouldn't. So repeat once for the first. Yeah, but that's the question. Repeat once. Does it mean that you have 2 values? Or that you have one of them only? So the example here is the third one. Okay. See, a lot of you are finishing. That's very good to see that. I think I'm getting quite close. So I am repeating too many times. That is what is happening. And also apparently I've replaced it with 2 instead of position. Oh man, that was actually while I was debugging that I did that. And so we should repeat it once, like this, and rerun it. And then play one step. Okay, now the first line looks a bit better. And it is matching as far as I can see. 1, 0, minus 1, 0, 1, 0, and minus 1, 0. Correct. And now I think that we also need to use the absolute, because we are taking only the rightmost digit. But for cases where we have negative values, we don't want to keep negative values. So I think it's probably going to work if I just run it. And after 4 phases we get a certain number. Let's print. Oh, it is already printed. And let's print also the phase. Like this. So let's look at phase 4. So after phase 4 we have calculated all of the digits and we get... Oh, wait a second. Maybe I should look at phase 3 actually. Because that one... Yeah, phase 1 is like 0 in my code. Okay, this looks not correct actually. So let's go phase by phase. Right, we run it and we see that digit 1, what is it calculated as? Let's also print that. So the new digit is this one, last digit, and print it. That is going to be from. So I want to show like the big digit and also I want to show the last digit that we're going to use. Maybe I can do it like this, and then I'll show the new digit and I'll show it as a string. Maybe I can divide it by 10 and then remove the remainder, and then as a second argument I'll use the new last digit, and then you can actually see both parts of the digit. So we are running. One more iteration, and then you can see the digit that is calculated was -16 and will take 6. And is that correct for the first value? No, that is not correct. Even though here it does look, the answer should be 4 for the first digit, right? But why do we get -16? It looks like even that our values are correct. I am adding the digit and multiply it by the pattern value. Pattern values seem to be correct. Okay, so 1 times 1 is 1, no 2. 1 minus 3 is -2. The plus 5 is +3. Then subtracting 7, -4. We should get -4 actually. And here is what we say here. So that looks a bit wrong. Maybe we should do first an absolute and then do division. Although it doesn't seem to make sense that you should do that. The pattern values are correct. We do have integers, right? The patterns. Yes, they use digits like integers. Okay. And I'm not sure why that doesn't work. So we're just summing it. And the digit we get is not the right one. Maybe I should log new d before I override it. No, I don't override it actually. So this is the new digit. Let's call it new d sum instead. And then, well, that doesn't really help. Braces don't help. Well, as long as I'm looking at it, it looks like it's correct. But for some reason we get a wrong output. That could be if we are working with strings instead of digits, for example. But here I'm casting it already. Let's just go over the loop and see what's going on. With debug mode on, of course. So we are now here. And we're going to loop over all of the digits. And we are skipping one pattern, so that's fine. And we are taking a certain digit from the array, which is number 1. We're taking a pattern value, and that is 1 also. And we're multiplying it. So we're doing 1 by 1. And then afterwards our new sum should be 1, and that is actually what is happening. Then we take the second digit, it's the 2, and we take a pattern value and it's 0, and we are adding that to the sum and we should get still 1. And we do. Okay, so we are taking 3 multiplied by -1 and adding it, so we should get 0, right? Oh, hold on, no, we should get -1, yeah. 3 times -1. That works also. Then we get 4 multiplied by 0 and we should still get the same -2. And then we have 5 multiplied by 1 is +3. Yeah, we get +3 as you can see. And so on and so on. I'll keep going until the digit is 8. So now it's 8 and we're doing that. And so we have 4 in the end. And are we going to keep going? No, we're done. And so here now, this is the part where it might be wrong. No, we still get 4, that is correct. But the new last digit is 4 and that's what we're going to return. And here I'm appending it to the list of digits, and the list of digits is now empty. 0. And let's see, then we're appending it, and then we just have digits equals 4. Ah, and then I'm actually showing here, maybe not actually what is necessary, from 0 till 8. Let me just print all of the digits. I think my range was incorrect. So how does it look like if we have something like this and we take from 0 till 8? We actually do take the first 8, so there's nothing wrong with that. Still a mystery what is going wrong. Now we do get -1 and a 4 instead of a 6. Really, I feel like some funky things are going on here in my Python. Good job, Valerie. Part 1 done. I'm still working on it. So, and we're printing 1. Well, that is incorrect. Oh no, that's phase 1 actually. So the digit we're gonna use is 4 and it's fine. So why did I get different output before? Why, when I ran it like this? Well, that's something I'm going to look at later when I'm looking back at the stream, of course. But so this looks fine so far. We have 4, 8, 2, 2, and so on. And then we're going to do the next phase, and it gives us something different, apparently. 3, 4, 0, 4, 0, 4, 3, 8. Okay. So that is not using the right digits as input, most likely. Or something else is going on. And how about this skipping? Maybe we should skip it. Ah, yeah. We should not skip it every time. We should skip it only once. So that means we should skip here the pattern, like here. I think I already did that, but let's just see how it goes. So that's the first step, and it's the same as before. Then the next step. And now it looks like, yeah, 3, 4, oh. But the example says 1, 4. Okay, so we're still not skipping correctly, most likely. Let's see if I read it correctly. While each element in the output array uses all of the same input array elements. Okay, I'm just going to check the first digit of the second phase. So phase 1, that's here. And that looks like 4 multiplied by 1. I have 4 multiplied by 0. And why should it be 1? Because we have a repeating pattern like 1, 0, -1, 0. And then 1, 0, -1, 0. Okay. 1, 0, -1, 0. But in our case, we're multiplying by 0. So I think... So it was correct the way I was doing it. We do need to skip for every digit 1 letter, one value. Yeah. And I just hope that this pattern is going to be a reference and not a copy or something. I think it's going to be a reference because it is a cycle object, which is a generator. Okay, so let's run the code again. That was the first phase, and then the second phase is here. So first phase, the output is correct. In the next phase, we're going to calculate digit 1. But why do we still get, again, the multiplication by 0? That is not right. And our patterns... Let's look at our patterns a little bit more critically. So, the example here was the second element, and the first list would be like this. So we are going to break before the loop and use evaluation to actually produce the patterns. So pattern 0 should start with... Oh, hold on a second. This is an example for the third one. This is an example for the second one. Okay, so let's start with the example for the second one. Patterns, yeah. So then it would be 0. Oh, then I get another 0. Yeah, okay, so we haven't skipped it yet. Right. Okay. So now I feel like this first skip should actually be here in the patterns. And I'm going a little bit in cycles here. So let's do it again. We get a history, yes. So we actually should get... for the second element, the output list, second element of the list, this would be the pattern. And we get 0, then a 1, then a 1, then a 0, a 0, and a -1, and a -1, 2 zeros, 1, 1, 0, 0, -1, -1. Okay, so actually that is correct. So, now the question is, do we pass on the right p value? Yeah, it's positioned in the list, and we're adding to the digits, and we're calculating new digits, and we're passing in the old array. But I think, yeah, we're working with strings here, and then in the second iteration we're actually using a list, and I think there's something not right about that. Maybe we should actually make a copy of the list and do it like that. Let's do that. Okay, let's run it with debug on and see where we break after the first iteration. That's our first list. 4-8 ending in 5-8, that is right. Another step and it looks like 3-4, and I still get 1. Why is that? When applying the pattern, skip the very first element exactly once. Offset the whole pattern left by 1. Okay. After using this process to calculate each element of the output list, the phase is complete. Okay. Maybe I missed something else. Each element in the new list is built by multiplying every value in the input list. But is it the original input list, or is it perhaps the last phase? I think it's the input list from the last phase, but maybe not. Okay. Let's look at the example. We do calculate 4 and 8. We use 4 and 8, and that is actually the values from the previous phase. So we do use the previous phase. And as you can see, I am also doing that. So in phase 2, this was phase 2. You can see that this was the first phase. Hold on, it's very correct. You do use 4, 8, 2, 2, 6, 1, 5, 8. That's really correct. And then I'm using 1 and 0 and minus 1 also, and then 2 times 0 and a 1. That's also fine. 0. Yeah, so the first iteration is correct. We get the correct calculation and we get a 3 out of that. Then the second line is 4 times 0 times 8 times 1, 2 times 1, 2 times 0, 6 times 0, 1 minus 1, 5 minus 1, and 8 times 0, and we get 0 as an output. So that is also correct. But then the next one. Why do I do 4 times minus 1? That is really not right. I should do 4 times 0 also. But basically what you can see here is that the number of zeros in each step is ever increasing. So it's kind of like a matrix, sort of matrix. I feel that waking up at 4 AM today is really taking a toll on my productivity on today's puzzle. So if there's something super obvious that I'm not seeing, feel free to give me a tiny hint. I think it's just a matter of sleepiness right now that I'm not able to recognize where I'm making a mistake. I think I'm going to test the second pattern also. You think it's quite confusing? Well, yeah, it is confusing, but I do feel like if you follow every step very carefully, it is kind of clear, but you just can't skip anything. But I just don't see why. This is the second phase, right? Okay. So my second phase is where it's going wrong. Here I'm multiplying by minus 1. But oh, wait a second. Okay, hold on. So how do we calculate this 8 here? That is, hold on, it's the first digit of the input, which is here, and then here is the first element in the pattern for position 1. Then we've calculated this first digit, and this is the element in the position for, hold on, this is pattern 2, right? And this is pattern 3, this is pattern 4, and so on. Okay. But this is also pattern 2. So the patterns, you can read it like this: 0, 1, 1, 0, 0, minus 1, minus 1. Okay. So let's see what our pattern looks like for the second item, if it really goes right or not. So let's evaluate the patterns. And then the 1 at position 1. So I'm looking here and I'm going over every right hand side of the equation and to see if it matches up with what I get from my console here, from my evaluation. So we start with a 0, then we get a 1, then we get a 1, a 0, a 0, a minus 1, a minus 1, and a 0. And then when we continue, we should reach what we get for pattern, phase 2, which is starting with a 0 again. And because this is the second pattern, normally you would expect to have 2 zeros there, but I see only 1 here. So let's have a look. We do enter and we get a 0, and now probably my code will give a 0. Oh no, it's giving a 1, because I'm skipping only once. Okay. Then we get another 1 and then 2 zeros. Yes, and then 2 minus 1s. We did, and then a 0. Okay. And then for the next phase, we should get this part here. So that means starting with a 0, a 1, a 1, a 0, a 0, a -1, a -1, and a 0. That all looks fine. That all does look fine. So I think actually the pattern here is correct. And here we should just not skip anything that we don't need. I am looking at the correct position. I'm kind of sure about that. But I feel like I'm doing next somewhere where I shouldn't. No, in 2 positions. Once while building the patterns, and then another time. Okay, what about the third phase? What about the third phase? So, is my evaluation still on? No, it's not. So I'm going to have to repeat what I just did, which is alright. I'll just press 8 times. That was 8. And another 8 times. That was 16, and now we should get a 0, and then a 1 and a 1. We get a 0 and a 1 and a 1. And then 2 zeros again. And then twice -1 we did, and another 0. So really the pattern for the second position is correct, but maybe it's the third position where something is going wrong. So the third position has 2 zeros at the start. It's right here. Hey, let me select that, please. Okay, we start with 2 zeros. 0 and a 0, and then 3 ones. 1, 2, 3. Then 3 zeros. 1, 2, 3. And then we go on with this one. We should have 2 zeros. 1, 2. Oh, but we get -1 now. Oh. Why is that? Why is that? Why? What happened to the -1s in the pattern for position 3? We should have 3 zeros, but we skip 1, then 3 ones, 3 zeros, and then why don't we get -1 here? Because that was the base pattern, right? And for the second element there is an example, and the example for the third element is also like this. So maybe the way I'm repeating my chain is actually incorrect, but it would be very surprising to me if it was incorrect. We're repeating a digit a number of times for every digit in the base pattern. That's it. That should be good enough, I think. So let's do actually a few phases and print all the patterns. For phase in range, let's do 3 phases. Print next pattern, and we're gonna do the third item, and we'll print, maybe we'll print it without an ending, and we'll just add to that a comma, and then we'll print a new line. So we run it. We cannot subscribe to a cycle object like this. Patterns. Yeah. And now we are trying to add things to integers, strings to ints. So let's do it again. Now we get 0, 1, 1. Hold on. I'm doing 3 phases, and then for each phase I should iterate the number of digits. Yeah. For D in range 0, then digits. Man. Oh, and of course I need to make that into a good looking loop. So this is the pattern that I produce. 0, 0, 1, 1, 1, 0, 0, 0, -1, -1, -1, 0, 0, 0. Okay, but maybe we should actually start from the start every time. Yeah, that's what it looks like actually. So we have to generate the pattern for every phase instead of the way I'm doing it now, which is making it once and then repeating that one. Okay. I agree with you, Emily. Today's puzzle is confusing. Yes. It would be nice if there was a step 1 where you would, like a part 1, where you would actually validate the pattern. And I see that no one has finished part 2 yet, unless my leaderboard is broken. Let me just have a double check. Part 2 is not solved by anyone. Oh my god, that is not a good sign, and we're already in for 1 hour and 16 minutes. Well, part 2 is going to be a while, and you're already working on it. Okay. That is not good news, my friends. That means we're gonna be stuck or not going to be able to finish. It's kind of like day 10, part 2. What was day 10? I'm just very curious what you're referring to. Day 10 was the monitoring. Oh no. Oh god. Yeah, okay. But the monitoring station didn't have a trick to it. At least not for me, I just brute forced it. The end body's problem was something with a trick. Maybe are you referring to the end body? Yeah, exactly. Yeah, okay, well, we'll see. This is all numeric mathematics. Let's see. Reformatting a little bit. That doesn't work. Okay. So we need to reinitialize the pattern. And that means I'm going to make a function that is called def. That's called getPattern for a certain position. And then we'll just return this one. And we also need to say how many. We need to specify the base pattern. Not really. We have it as a global. And we'll return it. And the next is actually part of it. The pattern is like this. We'll do next. And then we'll return the pattern. Get pattern for position P. Okay. So that means that our patterns are actually a list. Well, you know what? I'm not gonna keep the patterns. If that's how it works, then let's not do it. So to calculate the new digit at a certain position, we just need to know the current position, and we'll calculate the pattern. Get pattern for position P. Right? We'll use the pattern only for one position, and once it's done, we don't need it anymore. So this looks a bit better. Let's run it and see how far we get. We get an index out of range because of this test code that we no longer need. I'm now assuming that it's going to be correct, but calculate new digit no longer needs patterns. Yes, it is well said by our Python interpreter. So now we have phase 1, and at the end of phase 1, no, that's digit 1. At the end of phase 1 we get the following number that is matching, and then for phase 2 we get okay, yeah, my phase 2 is actually called phase 3, so let's fix that and make it a little bit more clear. So we'll run it. Oh, this is not okay. Maybe like this. And so just right before phase 4 starts, we have the output of phase 3, and we get something that looks correct. So now I will actually... Okay, you know what? Let's run it also on the other examples to be sure. It's a lot of output, and in the end we're printing those digits. So our input would be this one, and we'll run it, and it takes a long time. So I'll also remove some of these print statements like this, and we get 2, 4, 1, and so on. Okay, so I'll actually join it also so that we can easily copy paste it into the answer. So we'll run it on the real input. There we go. And now we get a problem. We are expecting something else. I'm joining digits and you cannot join integers. You have to first convert them into a string. That's something I don't like. I wish Python would automatically fix that for us. For the in digits. And I don't want to join by a dot, I want to join by nothing. And I do want to also show only until position 8. And the phases take quite a long time to calculate, I would say. Good morning, G. How are you doing? How's it going? I'm waiting here for the output of part 1. I just finished part 1 and it's running. It needs to run 100 phases and then we should get a number. Man, this coffee is so weak, I think. It's almost like I forgot to put coffee in it. Alright, let's see. Yeah, it's correct. Okay, well, finally one part is done. You just woke up and you want to say hi. That's super nice of you. Hi. Good morning. Well, brace yourself. Part 1 is kind of okay. Do take care to read instructions very carefully and maybe take notes. I'm not going to give you any spoilers, but just to say that there are a lot of instructions and you need to get them right. So let's commit this piece. Commit. And so, by the way, yesterday I wasn't able to finish puzzle 15 on time, but I woke up very early today to finish it and I made a recording. So after this stream is finished, I will also upload day 15, which has the end of part 1 and 2 in it. So do have a look at that in case you were curious how it ended up with the oxygen finding robot. Yeah, it was very fun, and I must say I'm getting very good at breadth first search. Yeah, I feel like it's now not a problem anymore. It's just a bunch of loops and 2 lists and that's it. And also because we're discussing how we're solving the problems, it really helps to kind of get it more stuck into your brain. Where am I going? What am I doing? I was committing. Yeah, that's what I was doing. I was committing my file so I wouldn't lose anything. And still no one seems to know why my commit message is always one from many days ago. Why? Day 15, 16, part 1. And then I always have to commit twice for some reason. Another bug, seemingly. Okay, now that your FFT is working, you can decode the real signal. The real signal is your puzzle input repeated 1000 times. Okay. Treat this new signal as a single input list. Patterns are still calculated as before, and 100 phases of FFT are still applied. Oh my god. Oh, you made something amazing? I want to see that. Let's have a look. Let's have a look in my other window. Ooh. Ooh. This is fun to look at. Wow. Oh man, end curses is so cool. Wow, that's amazing. You also used a net sign. Everyone is using a net sign, it seems. Wow. Oh my god, this gives me shivers. It's so cool to look at. Ah, and then you're doing another search. Whoa. Haha. Super fun. Huh? Why are you doing that twice? That didn't make sense. Why are you doing a breadth first search twice for the oxygen? Or do... Okay, can I replay that last part? Yeah, and also it's not filling up everywhere. So you're having stars here. Oh, I think you're walking back the robot to the... No. So you're looking for the oxygen tank. Hold on a second. Follow the wall on the left to build a map, then A star to the oxygen, and then flood fill. Okay, so you're building the map, following the left sides. And where do you start? You start at this kind of... You don't start at the arrow sign, actually. Okay, so the arrow sign is the oxygen tank. And then once you found all the locations, then you're going to start from where you are and going to find the shortest path. Ah, yeah, right. So then you find the shortest path to the oxygen tank. And then you're doing a flood fill. And the question is whether or not Crespel did a star. Ah, so you did do a star, not a breadth first search. Okay. And so you used an estimation function then and a priority queue or something? Maybe we can have a look at it. Well, it looks very cool with the colors and all. And Emily, you also made something. Let's have a look. Wow. Oh, does this actually work? Yeah, it works. Cool. I have a full screen view. But it might run out of the screen. Wow. But how did you do the colors? Is it visualizing the depth or something? You're taking the minimum and or like a gradient from 0 to 255 based on the maximum depth. So are most people doing the Advent of Code for Twilio Quest items or what? What is Twilio Quest? Something important I'm not aware of, apparently. Emily, that's very beautiful. Thanks for sharing that. I wish I also made some more visualizations in this Advent of Code. Last year I had so much fun making a visualization of the waterfall. I should kind of show it actually. Does anyone remember the water simulation from last year? I will show you right now what I made. Yeah, I will show it. But now you're gonna see all the crappy videos that they're promoting here locally. I need to go to my channel. Hold on a second. Yeah, I'm just looking up my channel and finding the right video because in Safari I don't have a quick link. So my videos, let's see. So I have two. So the first one is this one. And this is a simulation of the water simulator running on a custom map. So normally... Oh wait, I have to log in. That's not correct. 1 second. I think it's public, so I shouldn't need to log in. Okay. So the normal map looked like a bunch of buckets basically, and I wanted to see if my simulator would work also on a custom map. So I made this. Let's put myself on the right side. Yeah. So that was the first part, and it kind of just slowly fills everything. And well, that's the kind of boring one. That's running in the terminal also. But then, as a second improvement, I wanted to see if I could make a very big one. You might have to go back and do last year's. Yeah, it was a lot of fun. This was one of the trickiest problems though, actually. So the mission is to actually simulate how the water flows, and you have to say like how much water is in the buckets or something that is not moving. And so the second part that I made, and this one is a bit crazy. I wanted to run it on a bigger map, like a huge map, like a crazy huge map. And so I had to optimize it. And I ran it in Canvas with, I think I made it in React, maybe Kotlin compiled to JavaScript, or maybe just plain JavaScript. So what you see here is a map similar to the one generated in the puzzle, and you're going to see water flowing. And I'm not sure, oh yeah, it starts at the top. Oh, it's jumping a little bit here. Okay, it's coming, it's at the top, and it's very small. But I'll just play it for a little bit so you can see it. Yeah, and it's huge, so I had to optimize a lot because redrawing every pixel, for example, you cannot do that. And so I had to kind of find ways to make it run fast. So I'll skip a little bit through it. And here you can see it like a little zoomed in version of it. Yeah. So that was my visualization from last year. I also made some other things that I can show later. Yeah, I'm not sure how much time it would take me. I think I'll probably take another session and show you something else that I made last year. It's kind of based on this waterfall. I wanted to make an automaton, a cellular automaton that could simulate the water, rather than, you know, really like... oh, wait a second, I think this might be a cellular automaton. Yes, it is. I forgot. So this is actually a cellular automaton, so as you see, the water is really flowing from left to right. It's not looking up the next wall and just flowing the water straight to the end of the wall as I was doing in the original solution. So it's a cellular automaton that is running like at 40 frames per second or something on a really insanely big grid. I'm quite proud of that. Alright, so let's go back to day 16. So what do we need to do? We are gonna work with a signal that is 10,000 times larger than before. And it's repeated, but if it's repeated, doesn't it mean that it's basically the same? How to say? No, the calculations cannot be done on the repetitions. Thanks, Emmy Flake. So the first 7 digits of your initial input signal also represent the message offset. The message offset. Hans has actually solved it. Oh, and Arcanian Archer has also solved it. I missed that actually. Oh, right. Okay, so actually people are able to solve it. That's giving me hope. But it has been 1.5 hours, so that is very long. And I think that I'm going to have to leave to take a train in half an hour. I will just read through the instructions to understand the problem, so I can think on it about it also on the train. But I'm not gonna be able to solve today right now. Yeah, but you started a bit later also, G. People are already solving. Yeah. Let's see, and Alex, you also finished. Finally. Good job. And this was really a hard one, so, you know, for some time I thought maybe this year Advent of Code is not going to be harder and harder. But it is getting harder and harder. It was a idle hope. And we are getting really into the depths of programming algorithms. Hey Arcanian, it was tricky. You thought it said we needed to run it 10,000 iterations instead of 100, so you tried to optimize using NumPy, and that was a waste of time. Man, yeah. It's still, even after 15 days, very hard to read the instructions carefully and to interpret them the right way. There's a lot of things to think about, and I wonder if taking notes could actually help, like just to write down every tidbit of information in a separate bullet point. Yeah, the lesson is to actually read, yeah. It took me a few iterations to read till the very end, but now I always read to the end. So let's read it. So the input signal is repeated 1000 times, and maybe I'll just also take notes as I read it. You might be able to see through the board a little bit, but I will read it out loud in any case. So we have the original input file, that is this one, and we're going to repeat it 10,000 times, no, 10,000 times, and this is the new signal, okay? The first 7 digits of your initial input signal also represent the message offset. So we have basically 10,000 repetitions of this. 0, 1, 2, 3, maybe not 0, maybe we start with 1 actually. Just a small detail that could really cause you to get stuck for half an hour. So we're starting with position 0 and the last one is 10,000. Here's a little skip marker, and then within the first input list we have 7 digits. Let's see how I can visualize that. It is, I'm not sure how long the original input is. I have it on the top of my screen, of course, and PyCharm says I have 650 characters selected, so 650, and out of those we're gonna take the first 7 like this. Hold on, let me change my mirroring setup like this. So we're taking the first 7 digits and that is going to be the message. And what is the message about? I think that this might be a little bit too small to see. I'll increase the size a little bit if I can. Yeah. Hey Fuzzy, good morning. How are you doing? Let's look. You haven't solved part 1, so I'm assuming you probably just got up or got ready and are going to start on day 16, right? I'm working on part 2. Well, not working, I'm just reading it. I'm not gonna have time to actually build and finish it. I think so. If it's so hard for everyone else, definitely it's going to be hard for me. So the message offset is the location of the 8th digit message in the final output list. Okay, that seems very crazy. So it sounds like what we're going to produce in the end, you know, we're going to have all these phases. So this is representing an input list of 10k, and hold on, like this, and we're doing a new phase and another phase and so on, and we do it 100 times. Then we do get a list here, and we have 1, 2, 3, 4, 5, 6, 7 digits that we can just read, but then digit 8, that is going to be read from another position in the input. So it's very, very, very long, and this message contains a number m, and we're going to look at number m, and that is going to be the 8th digit. You just got online. Enjoying today? Yes, I am enjoying today, especially because I just also finished day 15 before starting on day 16, and I feel very happy to actually see my robot solve the maze. And day 16 is alright so far. I finished part 1 and it was not too bad. I did get stuck on interpreting the puzzle. I did misinterpret it a few times, quite a few times. But there's something extra about this message. It indicates the number of digits to skip before reading the 8-digit message. The 8-digit message. What? Oh, no, it is the message offset of the 8-digit message of the whole message, not just the 8th digit. Okay, glad I saw that. Yeah, this is really like adding like all kinds of operations and things just to make it overload your brain a bit. It doesn't seem to like make a lot of sense. So we have the first 7 digits, and that tells us how many digits we need to skip. So this interpretation was incorrect. So it works like this. We have our input list, which is very long, and we have the message here, and it says now skip a number of items. So if it's 0 items, how many to skip before reading the 8-digit message? But do we skip from the start or do we skip from after this 7 digits? So for example, if the first digits would be like this, the 8-digit message would be the 8 digits after skipping 1 million, blah blah blah, of the final output list. So if the message offset were 7 and your final output list was this, then the message would be 21. So that would be here. So that means we're skipping 7. So the message contains the offset relative to the start and not from the end of the message. That is also very important to get right. So we have a message starting somewhere over here. The message is starting here. It's telling us to skip a number of steps from the beginning. So basically 0 means starting at position 0, and 15k would be starting at position 15k. Okay, anything else about this message? Here's the 8-digit message in the final output after 100 phases. Okay, so basically we don't need to change anything except that it would run forever. So if we take example, let's just first see if our algorithm works on what we on the examples here. So what is the 8-digit message embedded in the final output list? Okay, so the message is actually not this one. Let's just print it when we're done. So we're printing the digits and we're gonna join it by nothing. And okay, I'll just copy this. Why not? Just copy the whole thing anyway. This. But we shouldn't start at position 0, we should start somewhere else. And now I don't know if the 8 actually indicates the length or the last part, so let's try with another offset. No, we actually stop at 8, so we don't take 8. What we could do, of course, is to start at position 3, for example, like this, and then take 8 from there, like the first 8. No, the last 8. No, hold on a second. So if we want to start somewhere, we should skip a bunch of items. So let's say we skip 3, and then from there we're going to go from 0 till 8, like this. Yeah, so I don't have to write the 0. So now we get 8 items starting from position 0. I'm going to do the same thing here. We're going to skip a number of items and then take 8. And I'm going to skip how many? I'm going to skip the digits from 0 till 7. That is going to be a number, but I first have to make it into a number. So I'll do that by first joining it into a string. Oh man, this is going to be very ugly. M digit or MD in digits, and we need to first cast it into a string before we can join it. And let me keep track of my parentheses here. So this is actually going to skip a part. And so this is going to be joined also into a string. Then we have a number that we can parse. Yeah, very ugly. And that's what we're going to print. Let's see how that works. This is the next out of range. Maybe I'll just first determine the message. No, the message offset. And that should be this one. Offset. And the range is actually from 0 till the message offset. So that is... Ah yeah, now I got a bit lost, I think. We need to skip a bunch, so that means we start with the message and then until there. And then we might want to print it, but we don't see anything. So let's look at the message offset. And for the example, the message offset would have been this, maybe. But I don't think that could be true. We need to look at the original input and not at the output. So input digits, that's what I'm going to save. That was the mistake. And the message offset should be like this, but that looks incorrect also. Maybe we can make a copy first before we are starting to mess up all of our lists. And it says that we have 0, 3, so 4 digits out of those should be 30,000 something, and that's what we get. So that is actually fine. But why? Note that the inputs given below are repeated 1000 times. That's okay, that's something I haven't done yet. So for part 2 we're going to have to repeat it. Times 10,000. Maybe it works, maybe. And then the message is actually from the digits, starting from the digit offset and then taking 8. That is like this. And then the last part will just print it. And let's print the message itself. And I think it's going to be an empty list for some reason. Input digits is not multiplied, or it is multiplied in fact, but we do need to multiply the output then also, but I think we should be doing that automatically, unless of course we're working with only the digits. Okay, maybe I should just have output digits also. Digits, maybe input digits. And then a slice, a copied slice. And then instead of digits, we're gonna work with the output digits. So when we run the loop, our output digits are initially the input digits and a copy of it as well. And then we're going to override it every time. And here we have the output digits also. And then we're going to use output digits for printing the message. And yeah, now it's actually crazy slow. Crazy slow. Yeah, I see why it's not possible to solve this even. Oh yeah, I was thinking that this is just a small example, so it would run kind of fast, but I didn't realize that this one is also going to be repeated 10,000 times. Yeah. It's very complicated today. Yep, it is. And so phase 1 has been running now for about 20 seconds and it's still not done. And so we are going to have to really look at how the numbers are added up. And so I'm just going to give you a hint of how I'm going to approach it, but I will do that later. Maybe tomorrow morning before day 17, or maybe in the evening. I'm not sure yet. So I'll show you what I'm thinking about right now. So you have, I think you're probably recalculating the same thing over and over. So that could be one thing, like kind of seeing if you can store intermediate results. So let's say we have a list with 4 numbers, and to make the new input, the new digits, we're going to combine all of them, right? We're going to combine this one and this one and this one and this one. And each of the positions has a pattern. Like, you hated that weird ampersand, that weird modulo 10 thingy. For positive x it is... Huh? Oh, but you could just use absolute. Why not? Yeah, taking the right digit is annoying when you have negatives, but just use an absolute. So we have pattern 0, 1, minus... Wait, it was 0, 1, 0, minus 1. But this didn't allow you to add several rows and do the ampersand, the modulo 10 later. So I guess you're talking about part 2 then, most likely. Yeah. Okay. Okay, I haven't realized the complications of the modulo yet. So I think I will stumble upon that later. So my idea in general is that we're going to do similar calculations many times, most likely. And how do I know that? It's because the patterns are always, the multipliers are actually always 1 or 0 or -1 and nothing else. So that means that we've calculated a lot of values twice, but I guess the bottleneck is not so much calculating like 1 multiplied by -1 or 5 multiplied by -5, and probably storing that result is not going to help a lot. So we're going to have to see how we do that. I think another insight is that the patterns are shifting. So if you look at which pattern you use for each position, you'll see that the first pattern has 1 there and the other ones have zeros, and it goes like this. And basically what that means is this is actually a matrix which is in a certain form. I forgot what it's called, but there's a certain normalized form where one part of your matrix is all zeros, and if you have that, that means you can actually solve it as a system of equations. And I'm not sure if I'm just babbling or if this is really relevant, because 1, 2, 3, 4, 5, those are the digits of the number. Upper triangular it's called. Okay, so that is the name of this type of matrix. And wait, you use this system for equations to solve an unknown, like I forgot how it really works. But that's also something that I'm thinking of right now, and it might be relevant, but I think first I need to know what I'm actually trying to solve. So I think what I want to do is to know in one go, like what is the value for A in some way, and maybe I wanna solve this whole matrix. Yeah, maybe. I'm not sure. I'm still really not sure where I'm going with this. Well, anyway, that is all the time I have for now. I need to go to work. I will see if I can wake up earlier again tomorrow morning and solve part 2. But it's a very hard mathematical problem, and maths are really not my strength. Although I did study a bit of math, but really no more than a year. So yeah, I'm gonna try tomorrow. Thanks, G. I am going to have a day because it is now almost 8 AM here in Belgium. And for everyone else in other time zones, have a good night and good luck on part 2. And do check in with me again tomorrow and subscribe or follow rather if you haven't followed me yet. See you again, and it was nice hanging out. Bye bye.